Well, my name's Gregory, and I'm here today to talk to you about extended reality in shopper research and also consumer research. So first of all, just a little bit of an introduction to myself. I've actually been involved with augmented reality for about 14 years now, so going back right to the dark ages of it.
We'll see you at network.
I've also been involved with virtual reality for about 10 years now, so a little bit less time, but still longer. I've completed my PhD in computer science, exploring reality. And in this case, it was about making sure that items appear and virtual objects appear very consistent within the real world that they're presented in, particularly in interactive scenarios. So in my case, it was freehand interactions with virtual objects, making it all consistent and realistic. Back then, we called it augmented reality. Mixed reality kind of meant something else. It was a bit more of an umbrella term. It's got more of a definite meaning now. But it probably fit more in mixed reality today. But anyway, all of this led to me becoming a project manager at GSK Shopper Science Lab, which is where I've been for the last 4 years. We execute shopper insight projects using a range of high-tech approaches. And I'll tell you more about that in a moment. And just so you get a little bit of an insight to how I think, my design technology is lateral thinking of established technology, which is actually the principle that led to the Game Boy being developed. What this means is that while you can play with and test emerging technologies, new technologies, often innovation will come with technologies that you actually understand very well and using those in new ways. So it's all about using your existing knowledge in ways that can drive value and innovation. Okay, so who are we? So GlaxoSmithKline, I'm sure most of you probably know us as a pharmaceutical company. That's actually only one strand of our company. We actually have 3 areas in which we work. The other one is vaccines, which is separate to our pharmaceutical section. And then finally, consumer healthcare, which is where I work. So our consumer healthcare division, we produce products that you can buy in shops, that you will go into a shop and you'll see most of our products on shelves. And just like any other company that sells their products on the shelves of shops, we're very interested in what makes the shopper make their purchasing decision. How do they approach that product in the store? What's the journey they take? What's the psychology behind their selection? And then what happens when they take it home and consume it? And that's where the Shopper Science Lab comes in. We're the specialist centre for running these research trials for shopper and consumers. And to do this, as I mentioned, we employ a high-tech approach, often using things like eye tracking, facial expression analysis, and particularly virtual reality and augmented reality. So these are some of the products that we actually sell. I'm sure you probably recognise a great many of them. And we've actually just started a joint venture with Pfizer. So those last few products that came in there, they're ones that are falling under the banner of the new joint venture soon, so we'll be working with those particular products too. And altogether, this represents about £7 million worth of revenue. So it's not small amounts of money by a long way, it's a considerable chunk of business there. So before I start talking to you about virtual reality and augmented reality, I just want to take you through how shopper research is traditionally done. So for a brick and mortar store, what we'd do is we'd set up a physical environment. This would be a simulated lab, as it were. It would be a huge warehouse somewhere in which we brought in all the relevant furnishings, so shelving units, tills, displays, promotional displays, things like that. And then we'd stack it with actual products too. So these physical spaces, they're very natural in which we engage with them. And so what we do is we would have an interviewer and a respondent. The respondent's the person that we're testing, and we would send them through this store, and they would go on their general shopping journey, except we might give them some kind of task while they're doing that as well. So we might say, you have sensitive teeth, you have a headache, and we expect them to maybe factor that into their shopping journey when they select products. And for this, we can collect qualitative feedback. This can be through interviews during the study or post-study. From with the respondents. And we can also collect subjective data. So again, facial expression analysis, eye tracking, but also things like motion capture. So we can track their journey through the store, what products they've interacted with, where they pick them up from, where they put them back, that kind of thing. And this is great. So it's a natural environment everybody is familiar with. We've all gone shopping, this isn't too dissimilar. It's a very tactile, natural feeling. People can pick up the products, they can smell it, they can touch it, they can feel all the bumps on the packaging, everything. And it's very well understood. So we've been doing this for 100 years. The methodologies and the techniques for running this kind of research are very well established. But it's not perfect. There are a number of limitations to it. One of the major limitations is the large-scale A/B testing, which isn't really possible. Now, what this means is that if I was to, say for example, I wanted to try a signage route throughout an entire supermarket, I could basically hang those signs up in a physical space and ask the respondent what they think about it. But let's say I had an alternative route that had a completely different design. What I'd have to do is I'd have to take all those signs down, place the alternative up, and that's going to take a long time. The respondent's not going to wait around for me to do that. And even if they did, they've probably forgotten what route A looked like when they're asking to compare it, when we ask them to compare it against GDP. So that's one of the big limitations. Another one is that you can't test different store layouts. So let's say, for example, I wanted to test out aisles aligned straight on when you walk through the store against aisles perpendicular from the those are two radically different layouts, and I'm not going to be able to move the shelving units around to conduct that kind of study. So we can't test different store layouts very easily with a single respondent. It's also very expensive to maintain. You have to lease the warehouse, you have to bring in all the furnishings, you have to buy all of the products that sit on the shelf. An entire supermarket's worth of products, can be very expensive. You have to keep that refreshed as well, so every month you're buying in new products. It's also really time-consuming to set up a study. So to stack the shelf in the way that you want, to hang up all the signage that you want, to bring in the promotions that you want, it takes days. It's not a quick task and requires a lot of many hours to set up. So this is where extended reality comes into it. The business potential is the ability to rapidly gather enhanced shopper insights versus more traditional methods. And what I mean by that is that we overcome those limitations right there. In a virtual store, we can do that quick A/B testing. At the touch of a button, we can take out the old signage and bring in the new signage, and instantly we can ask somebody to compare them and say what they think. We can test two different store layouts. Much in the same way, we can ask people, what do you prefer? Store layout 1, press a button, all the shelving units change location, and ask them, what do you prefer, version 2 or version 1? It's also very cheap to set up. So it has a very low initial cost. Entry to using a virtual reality store is nothing compared to setting up one of these physical stores. You just need a very high-end PC and a space where you can use it, and a virtual reality headset or similar devices to start. You also don't need to buy in the products. You can just use a library of 3D models, and they already exist out there, and they're substantially cheaper. It also allows you to set up projects much quicker. You can just load in digital planogram files, so these are digital shelf layouts, and you can populate that automatically with virtual reality. So instead of taking days, it can take hours, maybe even less. And also you can run more respondents through per square foot of space that you have, because these virtual reality headsets, they don't take up much space. So before I get into VR, I just want to give you an example of how we use it. So in this case, what you can see is the shopper going on a journey throughout the store. So this is how we set up a project. We go into a real-life store, we take thousands of photographs of it, we build a 3D model of that store, we place it into a games engine, and then we load in our different variations of content. When we do a consumer or shopper research trial, what we do is we ask the respondent to take a journey throughout the store, Eventually, they might end up to the point of interest that we want to look at. So in this case, it's this promotion right as you come into the store. And then at the touch of a button, we can change the content that they're seeing. So maybe we start off with the yellow version, and then we ask, would you prefer the blue variant or the pink variant if the conversation heads that way? And so it's a great tool. It overcomes many of those limitations, but I think there's some considerations that we need to make. At this point, I just want to talk about the observer effect, which is often used in physics. It's a physics theory. I think it applies here. What it states is that the mere observation of the phenomenon changes how that phenomenon behaves. And I think shopper research in VR is no exception. If the shopper that's being tested, the respondent, is very aware that they're using VR, is encumbered by the fact that they're using VR, then this creates a barrier. It changes the way that they behave. And so we need to make sure that they're comfortable, that they feel like they can express themselves naturally. And for this, I think that there are three considerations that every project that needs to be made for every project. The first is the VR device being used. The second are the interface devices being used. And the third is how they're interacting with the environment. So first of all, VR devices. I was actually going to list out the different types of VR devices that you might come across, but I thought I'd turn them into a bit of a chart where on the x-axis I've got a level of immersion, and on the y-axis I've got scalability, which is I kind of broadly define as the amount of people you can get through a project in a given space of time. And all of these can be used for for shopper research projects. There is a bit of a negative correlation, which is a shame because if it was a positive correlation, we'd get to the ideal situation very quickly, but that's life. But I've just highlighted three VR devices that I think you're probably most likely going to be using at the bottom there. Okay, so the first one is a high-end large 2D screen. Now, when I say large 2D screen, I don't mean your 90-inch LED at home. These devices are 5 meters and above wide, 3 meters tall, and they're incredibly immersive when you're standing in front of them because they fill your entire field of view. They have to be very high resolution to do this. I've said 4K there, but in reality it needs to be 8K or 16K. And the colours need to appear really good. They need to appear very close to real life. And there are also advantages to using a large 2D screen like this. So first of all, it allows interviewers to gauge facial responses of the respondent. So a lot of the time, when the interviewer is asking questions, they'll want to gauge the respondent's reaction to them. They'll look in their eyes, they'll look for signs of maybe disgust, happiness. This can be a frown, this can be a smile. So having that face-to-face contact allows you to gather qualitative data in a really effective way. It also is very familiar to me. They walk into the store, they walk into the room where the screen is, and they go, wow, that's the biggest TV I've ever seen. And then they forget about it. It's not an amazing piece of technology to them. It feels very natural, it feels very comfortable. So they're not very distracted by it. One of the biggest disadvantages, though, it has the potential to break immersion. So as people are looking around when they're using one of these screens, they might look to the right, they might look behind them, and all of a sudden, they can't see that virtual environment anymore. So for a brief period, they're taken out of it, and that can be quite distracting. So if you do want that fully immersive experience, you might have to go for a high-quality VR headset. Now, when I say a high-quality VR headset, it has to be rendered on a PC, a very powerful PC. It has to be very high resolution, and the setup has to look perfect. The detail of the scene has to look great as well. So not only is this immersive, it's also cheap and very scalable. However, the disadvantages are that the interviewer can't gauge the facial responses. So those frowns, those eye wrinkles, those nose wrinkles might signal something to the interviewer. All of a sudden we've lost those. And that makes asking the right questions to gain the right qualitative data very difficult. Now, this is fine for quantitative data. If you want to do eye tracking, for example, you can use the VR headset. But for qualitative data, I think it has an impact. So that's the kind of the downside of that. The other thing is that it blocks effective communication in terms of the interviewer can be this disembodied voice asking questions to the respondent. They might not necessarily be so comfortable with that idea that somebody they can't really see is asking them a question. They can't look them in the eye. So they might not necessarily give the answer that they would naturally give under the circumstances. There's also potential for sickness, but I think everybody understands that pretty well. And then finally, the cave environments. So in this case, the store is projected onto screens that completely surround the respondents. So they're in a highly immersive environment. And this is great, except it's quite expensive to set up, and it's not particularly scalable. But I think the key message here is that no one device is going to be ideal for all of these situations. If you want that qualitative feedback, if you want people's opinions, that kind of subjective response, then go for the high-end large 2D screen. It's going to make life a lot easier for the person doing the interviews. It's going to make reading those facial expressions a lot easier. If you're interested in your quantitative, objective data, your eye tracking, your motion tracking, that kind of thing, then the high-quality VR headset will do really well for you. That's where the level of immersion comes into play. So if you're not interested in quantitative data, that will do really well. So interface devices. So respondents can actually explore the environment using the game's controllers. Just like a joystick in a video game, you give somebody one of these controllers and they're away. They understand it very well and they're off. The disadvantage with that though is that there's no direct interaction with the objects on the shelf. So you can't go in, you can't pick up one of these products and look at it and look around. So maybe that's where the wands come in. With the wands, people can actually move around the store with the joystick as they would with the games controller. And then when they get to the shelf, they can actually pick up the objects off the shelf by doing some kind of grasping gesture with the wand that's tracked in 3D space. So they can pick it up and they can look at it. The only disadvantage to that one is that the grasping gesture may require a bit of a sandbox for people to get used to it. And then finally, the gloves. This is very natural for people to just be able to pick up objects off the shelves and start to look at them so they can see what's on the products and so on. But the disadvantage to that is that the navigation is quite abstract, which could be problematic, so they might not necessarily know how to move around the scene. So just what we're talking about navigating around this environment. There are many ways in which you can do this. The first one is the obvious one, giving people a single location. This is probably what you want to use with those VR gloves. This is where you place somebody into a single location with no real option to move. They can take a few steps left and right, but at the end of the day, they're routed to a single location. Now this is great for those tasks where you just want somebody to look at a shelf and maybe pick up products from them. But you can't assess the journey up to the shelf. So if you want to assess the journey up to the shelf, maybe what you can do is use the teleportation technique. So this is really good for showing respondents multiple stimulus in different areas of the store. So you can go from area 1 outside the store, transport them to area 2, looking down the aisle, and then transport them to area 3, standing in front of the shelf. And all the way you can gauge their responses to that. So this allows you to maybe analyse the promotion that they see from the outside of the store, the shelving that they see as they look down the aisle before they even get to the shelf. But you take away the choice of the journey from the respondent. Maybe that's what you're interested in. So that's when you would give somebody the full control over their journey through the store. And you can track that self-directed journey, and this is great, but not everybody's always comfortable with it. Sometimes people can make mistakes, so there is that chance of error. But it's also quite difficult to sort of code some of the data. People might take different journeys, and if 10 people approach an aisle from one direction and 40 people approach it from another direction, then your sample size coming from one direction will be quite low, and the data won't be quite as good. So just before I move on to augmented reality, just to summarise some of those points, the VR experience itself should not act as a barrier to research. People should be able to behave the way they want. The level of communication should be maintained. The conversation should be free-flowing wherever you can. The devices shouldn't get in the way of doing that. And you should always go with familiar interfaces wherever possible. It's not fair to put the cognitive load on the respondent, making them do things that they may not normally do, because that's going to distract them and they might not be able to give you the information that you necessarily want. So, augmented reality, or I suppose this could be considered both augmented reality and mixed reality in this particular case. It has the potential to blend the benefits of the physical stores and the VR stores with fewer limitations than either. And I'll show you what I mean by that. So this is a video of us testing out 2 shelf layouts in an augmented reality shopper research project. Here we have a virtual shelf placed over a physical location in which the respondent can walk through the physical store and see as though there's a real shelf around it. And at the touch of a button, as you can see there, we've got a second variant of that shelf. And we can do this for all kinds of things. So here, for example, we're testing out signage. We might want to compare signage option 1 against signage option 2. Now, because we're doing this in a physical space, the respondent can navigate it as naturally as they would in the physical space. They wouldn't have that kind of encumbering elements of the virtual reality. It's more natural to them. But you can also do that A/B testing that wasn't possible in the physical space before. So that's where the power is with augmented reality. But there are some barriers still. This is an emerging technology, and I think there are a few things that we need to look at in order to do this effectively. So the first one is the type of device being used, second, the field of view, and then also realism. So first of all, those combined I've broadly categorized the 3 types of augmented reality devices that you might be using for this. Combined-based headsets, things like the Magic Leap, the HoloLens. What these do, they allow the user to see the real world through a visor, and once that visor is projected, the virtual content. These blend together so that you see virtual content over the real world, and it gives you a good connection, gives you good fidelity. But it has a small field of view, which I'll get to in a moment, and the content can appear quite ghost-like. So maybe you want to use pass-through headsets. They have a slightly larger field of view, and the content appears solid. But it also has quite a limited resolution, so you're losing some of that fidelity from the real-world environment. So somebody might not be able to read something like a shelf over there. And then finally, tablet-based AR. So if you're using your tablet with a camera, you can see the virtual content rendered over that real-world feed from that camera. And one of the big advantages of this is that it's actually a very familiar interface for users. Everybody's picked up a tablet and pointed it at a real-world environment before, so people aren't so distracted by this type of interface. Again, all of these have issues with field of view at the moment. And I think this is actually a really important aspect. So what this slide shows you here in the left-hand side is the human field of view, which is about 120 degrees. This is what we can normally see. Below that image on the left is the saliency map. So what this heat map represents are the things that are most that stand out the most to the shopper as they walk into the store. As you can see, where the red things are, that's where the most attention-grabbing elements are. Now, what I've done is I've got that saliency map, and then I placed a box, which is essentially your window to the augmented reality world over that saliency map, so you can see what you're missing out when using these devices. With the pass-through headset, you can see that on the left-hand side there, there's some quite interesting things on the shelf there that might take somebody's attention. But we're missing them out because they're in the periphery of somebody's vision. You can't show that using augmented reality at the moment. The effect is even more pronounced with the combined headsets. So you can see there's some really interesting items on that one shelf there, but the respondent can't see them because they're not covered by the augmented reality headset. This is improving massively. We've pretty much, I think, doubled the headset field of view in the last few years, and it will continue to improve. There's going to be a journey until we get there. The next one is realism. So I think there are actually 4 barriers to realism at the moment we need to look at: tracking, inclusion, lighting, and translucence. Tracking needs to be really accurate. As you can see with the inaccurate tracking there, that sign's floating about all over the place, whereas with the accurate tracking, it's pretty solid on the back there. Lots of new algorithms have been developed, which actually handle this really well. There are libraries in there for AR Core and AR Kit that will do this really well as well. And then if you want really solid tracking, you can use positional trackers like lighthouses or something like that. You can also use traditional markers if you want to, but that's up to you, because they might struggle at distance. This is something that's largely solved, but we need to think about it when actually doing consumer shopper research projects in augmented reality. The next one is occlusion. Now this is where I studied for so long, looking at occlusion. Occlusion is basically the concept of whether a virtual object should appear in front of or behind the real object. So you can see on the left-hand side there, with an accurate occlusion, that sign on the backboard appears over the sensor line, and that's not right. That appears very wrong. With the accurate occlusion, the image next to it, to the right, you'll see that the sensor line actually now appears above that sign on the backboard, and so that is correct occlusion. And people are very perceptive of this. An error of 0.33 degrees is enough to destroy somebody's level of immersion in that mixed reality environment almost totally. Now that's very small. You stick out your little finger like that at the end of your arm, it's about a third of what you can see there. It's a tiny thing that people notice. So we need to sort this out. And there are ways in which we can do this. There are time of flight sensors, but they're slow and they have potentially high levels of errors. You can also use occlusion meshes, but they're quite time intensive to build. So this might be a few years away. There's also accurate and inaccurate lighting, so we need to get the lighting really good. You can't really see on that projection, I'm afraid, but basically, we need to get the shadows looking right from the real world onto the virtual object. And there are ways in which you can simulate this, and they get a pretty good result for very low computing cost. So that's quite a good thing to do, but make sure you can do it. And then finally, the translucent appearance of some combiner headsets. So because you can kind of see what's behind them, if you're laying augmented reality content over a physical prop or a physical shelf, you're going to see kind of a blend of the two. And you're not going to really be able to get many good results from this at the moment. Because it's going to be very distracting for people. They're not going to be able to clearly read the pack or see the claims or anything like that. So at the moment, I think pass-through headsets and tablet-based augmented reality are what you need to use based on that. The combined headsets are improving, so soon we might be able to use these. And then just to summarise a few of those recommendations, tablet devices, they still play an important part in shopper research. People are less distracted by the device, the content appears very solid, and you can get robust tracking and lighting from them. It's a very scalable solution too. But if you do need head-worn augmented reality devices for research, then use the pass-through headset. The solid content and the field of view are going to be invaluable for you. And we're still a few years away from those combiner headsets, but they're getting better and they'll become practical very soon. And so on that note, I just want to talk about the KTP project that we just started with Birmingham City University between them and the Shopper Science Lab. Birmingham City University have a very large augmented reality research group that looks at the realism of the augmented reality content that's presented. And with them, we're actually running a number of pilots looking at how this technology can be used in shopper research as it develops and as it emerges. And as part of that, we're going to be writing a number of recommendations for delivering effective and valuable shopper research based on the data that we gather. Now, we don't want to keep these results to ourselves. We would like everybody else to share them. We would like to advance the science, as it were, as opposed to keeping it to ourselves. So what we're going to be doing is we're going to be publishing 3 papers over the course of the next year that provide that data, that provide a route forwards potentially for using augmented reality for consumer and shopper research. So keep your eyes open for that. And on that note, I just want to say thank you very much for listening. If anybody wants to ask me any questions later, please feel free to email me, ask me after I finish this, or message me on the app. Thank you very much.